Good morning, everyone. Happy April. John, do we want to just, today we've got Sean Levins from VDA talk about elevators, and John give us some updates. So John, if you want to get started, and just
Sure.
get me going. Thanks.
Yep, happy. Morning, everybody. Simple updates. We'll start with the BBRS and see where they are at. So they have been meeting. They last met on the 12th. They have another meeting scheduled in 8 days on the 28th. So what they have been doing for the last few months is doubling up on their meetings. Because what they're realizing is it's taking a lot longer to get through some of the, or maybe a better way to phrase this would be they've taken care of a lot of the low-hanging fruit with the codes, or at least the specific chapters of the codes, and now they're kind of getting into the real meat of the code and the portions, or at least the chapters of the code that really I don't want to say are contentious, but certainly have lots of differing points of views. So because of that, they're realizing it's taking a little longer, so they've been doubling up on meetings. Again, they're going to have one on the 28th. Apologies, I have a little animal behind me that's deciding to play with something. So give me 1 second and I will stop this animal from making noise. Can you hear the noise? No? Okay, then I'll let her
Hey, John, we can't, I can't hear anything at least.
Okay, good. So they are doubling up, just FYI, they'll be doubling up in May. So May, let me get the right date here. May, believe it's 11th. I'm sorry, May 10th will be their public hearing. So that's their statutorily required public hearing. That actually will be in person in Boston because that is a statutory requirement that the meeting has to be held in person and it has to be held in Boston. They will then also have another meeting on May 26th. That will just be a traditional meeting. That will be a remote meeting. They will again meet on June 14th, July 12th, and August 9th. And the June 14th and July 12th meetings will still be remote, but the August 9th meeting will be back to in person. As Megan and I and Josh and Sean were just talking, come July 15th, the legislature, or the legislation that allows for public meetings, not only state board public meetings, but also local municipal public meetings. The sunset date for any public meeting to be remote or allowed to be remote will sunset on July 15th. So then we are back to full-time in-person public meetings at least. So that is the BBRS schedule. They feel as though they're online. I don't know, and I don't think that for the upcoming May public hearing, I don't think that they're going to actually be ready to unveil the entire 10th edition for that particular public meeting, meaning they've unveiled it and they'll be asking people to submit comments on what they've unveiled. I'm thinking, just given their current trajectory, that they'll probably do a special public meeting, like maybe in June, where they will, prior to that meeting, they will make an announcement that the code is available for review and that they would like to receive public comments on what they are proposing as the 10th edition. But again, I think that'll be in June. That's my speculation. We'll probably find out a little bit more on the 28th at the next at the next BBRS meeting. In terms of what they've been covering, at the last meeting, they went through a few items that were sort of non-code related. There's a discussion that they have to engage around query reviews and putting in some potential policies and practices in place to deal with query issues and what they should do. about Corey. And for those that don't know, Corey is the background check that anyone has to go through if you're going to work in a public building. And that applies to design professionals and contractors and subs. The question that the board really is dealing with is because they do deal with licensing, CSI licensing and other licensing. The question is what to do if a Corey issue is flagged, and what do they do with the licensee who doesn't pass a Corey check or is found guilty of a Corey violation. So they need to have some processes and procedures in place so that there's consistency in what they do when that sort of issue comes up. They also addressed, I had mentioned that AIA was part of a large coalition of organizations that had submitted a letter to the city of Quincy. The city of Quincy has enacted some local ordinances that are building code ordinances, specifically around pedestal construction. And what they're requiring is any building that is done with pedestal construction, put these 12-inch tall, 10-inch wide letters on the front of the building, indicating what type of construction is used on that building for the walls and the floors and the ceilings. Long and short, we helped the coalition write a letter to the city of Quincy saying that it's our opinion that that circumvents the building code or usurps the building code. The board discussed it. Unfortunately, there's very little recourse for the BBRS because it's not a direct violation of the building code. Their hands are a little bit limited. Unfortunately, according to the legal opinion, what needs to happen is a general contractor or an owner of the building needs to file suit. And if they were to file suit, then the BBRS would have much more standing and be able to do something. But what the BBRS has agreed to do is they've asked council to begin crafting a letter to the city to let them know of their concerns, to let them know what the city could do to remedy by submitting the proposal as a code change proposal. And the board is also considering addressing the issue themselves by, since they're reviewing the 10th edition now, by putting a code change proposal together that would address the situation. And this is something I've talked with Andy and Tarika as the former chairs, because this issue has been around for a few years, that AIA Massachusetts is looking at submitting a proposal to try to resolve this issue. And the proposal would be something along the lines of, it would be evenly applied to all buildings, not just pedestal construction. But we're looking at something like maybe putting in a requirement for Knox boxes on all 4 sides of the building. And within the Knox box, there would be, say, an 8.5 by 11 sheet of paper that has a legend on it that really, the legend would be universal. And it would describe your wall construction, your floor construction, and your ceiling construction in very simple terms. And really the idea is that if the building is on fire, fire services shows up, they can get to these Knox boxes, pull it out, have an understanding of what the construction of the building is, therefore in a better position to be able to address the fire. We can also put Knox boxes next to the fire alarm control panel. The reality is we're open to the suggestions, but we're all trying to do is get away from the idea of putting 12-inch tall, 10-inch wide reflective letters on the fronts of all of our buildings for fire services to understand what the construction type is. So there'll be more to come on that, but that was a big discussion at the last BBRS meeting. Then they got into the code. They received a advisory committee update. So the structural advisory committee went through all the various changes that they've proposed for the code. So that took a couple hours to go through that, but the board reviewed it. There really wasn't an awful lot of comments. I mean, there were a few, but most of the comments were understood and agreed upon. Then they received a presentation from the Department of Energy Resources, the DOER Commissioner Patrick Woodcock, Ian Finlayson, who I think most of you know, and Paul Ormond, essentially presented the straw proposal, the straw code proposal to the BBRS. It was a good proposal. I would say that Carrie and others rightfully noted that the straw proposal as is currently constructed does not touch existing buildings in any way, shape, or form. It's all about new construction. So there was an acknowledgement of that and a request to the DOER to make sure, even though they're legally obliged to have to do this, there was a bit of a discussion saying, look, when you get into existing buildings, you're going to have to coordinate with the BBRS because that would obviously require changes to Chapter 34 and Appendix J, and that's in control of the BBRS. But DOER again made note that they're not making any proposed changes right now to existing buildings, but everybody acknowledged that by 2050, 80% of the buildings that will be in existence in 2050 already exist today. So everybody understands that in order to get to the net zero requirement that the state has for building emissions by 2050, we're going to have to get into existing buildings. But it doesn't appear as though we're going to do it with the 10th edition or the new edition of the stretch energy code or even the new municipal opt-in code. Then they moved on to, they started a review of Chapter 9, but at that point it was 1 o'clock, or actually it was about 12:30. The chairman of the FPFP committee, who is going to be presenting Chapter 9, said that at a minimum he was going to need at least an hour and a half, 2 hours to go through the changes, not to mention at least another hour on top of that, because the board will have questions and there will be back and forth between Department of Fire Services and the BBRS as to what these changes are and who rightfully, or what code rightfully these changes belong in. Not to mention, I'm sure Chapter 9 will make some, or the FPFP will make some recommendations that are likely going to be in conflict with the existing fire code. So those issues will get addressed and have to be worked out. So they've scheduled the April 28th meeting specifically for Chapter 9. So that will be the first item on the agenda. I suspect they're going to start at, they're going to go from 10 to 2. And so I suspect at least 3 to 4 hours of that time, if not the entire meeting, will be spent on Chapter 9. But I believe once they get through Chapter 9, again, I think that they're going to be at the finish line at that point, or very close to the finish line, and very close to being able to put out to the public to say all of the chapters are up on the website as they currently are, because as they approve them, they are putting them up on the website so anybody can see them at the moment. And they'll probably in the next month or so get to the point where they're going to make the announcement that here it is, this is what we're proposing for the 10th edition, so please start submitting your comments. So I encourage everybody to check out the BBRS's website. If there's chapters in particular that you're interested in, please check out their website. Most of the chapters are already there, except for certainly, pardon me, except for Chapter 9. But all of the other chapters, I believe, are there at the moment, or at least the vast majority of them. So again, if you have a particular interest, take a look, see where they're going. The key is there that describes what's in yellow, what's in red, what's in blue, because they have a certain keying system to identify what was in the 9th edition, what's in the 2018, what's in the 2021, and then what's being proposed, so you can understand what the differences are. With that, I'll stop, because that's the BBRS. That's probably the big thing that I think everybody's most concerned about, and just ask if there's any questions on the regulatory side or the building code side. No? Okay. Just flipping over quickly to the legislative side, we're getting very close to the end of the legislative session. The biggest issue is that last week the Senate passed the second climate change bill. Most of the bill, or the vast majority of the bill, deals with offshore wind and rebuilding, or actually building and rebuilding our existing infrastructure, and then building a new EV charging infrastructure across the state. As it relates to buildings, there were a couple items that are being proposed in there. One of them dealt with EV charging requirements on residential and commercial structures. That was a base bill, or it's a base language in the bill that would require conduit and wire for all new residential and commercial construction. Although some of us are arguing that's not really required because Department of Energy Resources has already made the exact same proposal as part of the base energy code for the 10th edition. And the BBRS has already accepted that, so it's just a matter of promulgating the code. There's also concern raised that if we put that requirement in state law that conduit and wire have to be run and your buildings have to be EV ready, the concern is what happens in 5-10 years when technology advances and we get to the point, for instance, where we're not needing EV charging stations for cars anymore because we can wirelessly, for instance, charge them. What do you do then? Because we have a state law that would still require us to put conduit and wire into certain locations or into all locations. So we'll see what happens with that. The biggest issue that I think everybody should just be aware of, we'll see where this goes, is the Senate proposed a pilot program for 10 communities. And what this pilot program would do it would allow 10 communities, think mainly Brookline and others, excuse me, to ban fossil fuel use in new construction and require electrification. And they would do this through their zoning codes. And while it's unclear whether this will pass, one of the questions that we are raising is, what does it mean? These communities that would be allowed to require through their zoning codes all electric buildings, there's nothing in the legislation that tells them they have to use the state building code, the municipal opt-in code, or even the stretch code. And our concern is that we want to close any loophole that would allow these communities to write their own energy codes. So again, we'll see where this goes. This only passed in the Senate. The House did pass months ago a very large offshore wind bill that was purely offshore wind and infrastructure redevelopment. The Senate bill goes much, much further than the House bill. There's only less than 4 months left in the session. And so we'll see what the House does with the bill. The way the Senate passed the bill, the most likely path is that sometime next week when the House comes back into session, they will likely appoint a conference committee, meaning 6 people, 3 from the House, 3 from the Senate, will get together to try to resolve the differences between the 2 bills, and they would have till July 31st to try to come up with that compromise. Given the vast difference between these 2 bills, I don't have a lot of confidence that they will make that deadline, but it all depends on what the House does, and so far they haven't done anything. So there'll be a lot more to come on that, but it's something to keep your eye on because in those particular communities, and Brookline would be the only one that I know of that would immediately qualify. I think 1 or 2 other communities, maybe Concord or Lexington, I think maybe pass similar zoning restrictions on fossil fuel use. So they would likely get into the program pretty quickly. But it's something to keep an eye out for, especially if you're going to be doing work in some of these communities that are clearly much more progressive communities like the Brooklines, the Lexingtons, the Concords, Somervilles, Bostons, and others. So more to come on that. With that, I'll stop because I'm pretty close. What are we, 8:24? So I want to make sure Sean has all the time he needs to go through the elevator presentation and just ask if there's any questions. No? Okay. I'm sorry, I didn't quite catch that. No, okay. I heard something, but I guess maybe it wasn't a question. So I guess with that, I'll turn it back to Megan, Josh, and John.
Thanks, John.
You're welcome.
Appreciate the update.
You're welcome.
And I forgot to mention this earlier, but we are recording. So we'll be able to post this to the website later. I will repost with the link for the continuing ed credits, and Sean, we'll figure out the sharing screen, make sure you can get this on, but Sean has worked with me on my latest project for at Feingold Alexander, and huge help. So I asked him if he could present to us kind of some basics, tie in some elevator code from Massachusetts, since we know it's unique and special. So without further ado, Sean, it's all yours.
Thanks. Excuse me. Thanks, Megan. So first off, can everybody see my screen here? Not the cheat screen, the actual presentation screen.
Yes.
Okay, excellent. So I'm a local elevator consultant in the area. I do recognize a few of the firms that have signed on here, so thank you for having me this morning. I am an elevator consultant, of course, and coming up on 8 years of working in this industry. I not only work in Massachusetts, I previously worked in New York City, which was about the same with their codes, pretty much a bunch of gray areas and not getting much done, more or less. But I also work in Rhode Island, Connecticut, New York State now, all the way up into New Hampshire and Maine. So, all right. Sorry, technical difficulties. Here we go. Okay. Everybody see that switch? Okay, excellent. So here's a little bit about the course information here. It is an AIA accredited course, so you got to get your credit somehow, I guess, right? So as I go through the course, I definitely encourage everybody to engage, either engage in the chat room. Hopefully I can see it. I'm a little used to Teams, so sorry if, I'm a little bit of a technical lag here, but engage in Teams, or, just unmute your microphone there, and please feel free to ask a question. I know this is a code-oriented group here, so hopefully I can meet your expectations as far as the codes. This is more or less like a basic outline course of elevators, but I'm going to throw in some explanations and some other things in there to kind of make this rather interesting and, kind of keep people from falling asleep on me here. Okay, so just going over the learning objectives. Again, review the basic elevator and escalator types, lift applications. Review the various elevator dispatch systems, operating modes, and whatnot. Basic elevator code requirements. And then evaluate the basic elevator application guidelines, traffic analysis, what elevators you're going to use for which applications. I'm pretty sure everybody's familiar with the machine roomless, but there is a hydraulic elevator, there's overhead gear, there's overhead gearless, and they all kind of require special situations nowadays, in which I'll definitely be going through. And then an overview of the elevator design criteria, and learn the basics of elevator traffic studies and whatnot. And also sustainability design with elevators, and how elevators are becoming green technology today. I'm a big proponent of that. It's nice to definitely see in the industry. Previously, they were pretty much considered dirty, not green at all. They didn't even get any lead credits or anything like that. But now you'll see through the presentation that they actually do qualify for some lead credits here and there. All right. Okay, so breaking it down, elevators, right? It's broken down into passenger service, freight, and even sidewalk elevators, which definitely do not meet code requirements these days. They're pretty much a rarity. I have done one for Yale, but it was an existing elevator, and that's the only one I've seen in a long time. They don't allow these anymore, for good reason, because they're a huge safety hazard, more or less. You can imagine an elevator popping up through the ground as you're walking down the sidewalk there. So next category is escalators and moving walks, of course. And then you have your next category, which is your specialty lifts, wheelchair lifts, which I'm sure everybody's familiar with, residential elevators, which you may or may not seen. That also falls under the category of Lula elevators, which are pretty much the same thing. Lula stands for limited use, limited access type elevators. Dumbwaiters or material lifts, which are used for little freight use, more or less. And then VRCs, or vertical reciprocating conveyors, which are used for heavy freight use. What you'll frequently see on job sites is what's called a rack and pinion elevator. They're basically the temporary elevator that's mounted on the outside of the building as the building's going up. So they tend to cost the general contractor a lot of money. So if you see them like trying to push for that construction elevator pretty quickly, that's why. It's because it's costing a lot of money on a day-to-day basis, more or less. All right. So going down into the types of elevators, and don't worry, I'm going to share pictures of everything and explain all these in better detail here. So hydraulic elevators are broken down into hold units, in-ground cylinders, and then you have your holeless elevators, right? Because somebody was like, digging a hole in the ground and putting hydraulic oil doesn't sound too good, right? So maybe we should think of something better. So they came up with the single and dual stage cylinders. And also the rope cylinders as well, cantilever designs, which you may have not seen. That they're pretty rare again. Not a fan of these cantilever designs just because they're defying gravity and engineering and everything like that. So they're definitely a rarity in this area. And then counterweighted hydraulic elevators, which is a proprietary type system. I'm not really going to go into it. It's more or less from it's called the MRL, but it's spelled EMARALE, I believe it is, not MRL like the other machine roomless elevators. And it's only to Mongrain Vertical Transportation, which is a Canadian company. So we don't really see that too often in this area. That was pretty much only in New York City that I've seen those. Traction elevators, you have your gear traction elevators, which I'm pretty sure everybody's familiar with. Gearless traction elevators, which are more for your high rise, and then pretty much what we're seeing installed today at 700 feet per minute and above, or your building heights of around like 300 feet of travel, more or less. And then the most popular, which I'm sure everybody's very familiar with, pretty much all new construction jobs these days is all machine roomless, or the MRL. But it's not technically machine roomless in Massachusetts, which I'll get to as well. All right, so as promised, here's the pictures here. So what you see in front is a hold hydraulic elevator, which is the most traditional and most traditionally used existing elevator that you'll see in buildings today, right? So it was very popular in this area. Some areas they actually have the old winding drum, which I haven't seen too many of them here. They are like scattered a few here and there throughout Rhode Island mostly, but not so much in this area. In this area, you're pretty much going to see a lot of hold hydraulic elevators, right? So the hold hydraulic elevator works through a pressurized hydraulic system controlled by the pump motor through that cylinder type, which is actually dug down into the ground for the entire length of travel, plus about 1 or 2 feet, right? So essentially, if you have like a 5-story elevator, it's like roughly 50 feet of travel, and that piston is dug into the ground probably about like 55 feet. So big issues with these was they were just single ply, more or less, jacks that went into the ground in the early days, right? And what happens when you have metal in contact with ground and water and whatnot? It rots, it deteriorates, it leaks, right? So the pistons would leak oil into the groundwater and everything else, which is not good at all, right? So then they decided in the early 1970s, right? 1970s, they said, all right, so start designing these jacks with double bottom type jacks, right? So that'll give it a little bit more resistance to the groundwater corrosion and whatnot, but these would still leak, from time to time. But sometimes they would just leak on one side, one partition, as opposed to the 2 parts of the cylinder that comprised of it. So you wouldn't get that leaking into the ground as much, but it still could possibly happen. These things have been in the ground. I've seen them for close to 50 years, more or less, and then a lot of times owners retain them just because they're really expensive to replace. So then in early 2000s, they finally got smart and said, well, why don't we encase this thing in a PVC liner? So that basically mitigates the entire ground and water contact with the piston whatsoever. So pretty much all your new installations for hold hydraulic elevators, which they do still go in from time to time, will have that PVC liner. And then additionally, with the modernization and the replacement of the jacks, you're also going to have that PVC liner or rubber liner around that jack to prevent that groundwater contamination as well. So every new jack that gets ripped out of the ground and replaced all has that liner installed these days. So these hold hydraulic elevators are very hard to modernize. They're very hard to change the types of systems. It's very expensive, especially in Massachusetts, because of the 524 CMR code requirements. So you're already kind of you're limited on your space because there's not much room required for a hold hydraulic elevator. It's pretty much just the rails that you need position for, and as well as the doors. So unless you're looking to downsize in the elevator car, which are normally just regular sized elevators, which you really can't downsize too much on to fit that counterweight system or possibly another type of system in that hoistway, then you're pretty much locked into to the hold hydraulic, unfortunately. Right. All right, so next they came up with the holeless hydraulic system, right? So this doesn't have the cylinders going directly into the ground. So the holeless hydraulic system works off of a 2-stage or even a 3-stage type jack system located on either side of the rails that kind of guides the car up and down the shaftway there. So the only problem with this is it's limited on the total travel, right? So the jacks come in stages of 12 feet of travel, and then a 2-stage jack is limited to about like 24 feet of travel. There are some manufacturers that will come up with a 3-stage jack, which they'll say is fine to be installed and whatnot, but excuse me. Seem to be drying out there. But again, the 3-stage jacks, what they have is a problem with the jacks synchronizing as they're going up and down the hoistway there. So when you have the 2-stage, you still have that issue with the synchronizations of the jacks. You know, you have the single stage hitting at one point in time, and then as the elevator rides up the shaft, right? Because nothing's exactly plumb these days. Then you have the 2nd stage that has to follow through as well. So both those stages have to be completely synchronized, and these elevators actually are on a timing system where they go all the way down to the bottom of the pit and they synchronize the jacks on a regular schedule, and it's usually done at night or in the early mornings to kind of synchronize that. But a lot of times these controllers, you know, that component doesn't work or something like that, so the synchronization doesn't happen. That's when you get like the banging, the poor ride quality and whatnot. So again, it's limited on travel. Like I said, 24 feet of travel. Some manufacturers will put in the 3-stage, but it's definitely not recommended. You won't see it on a VDA job, that's for sure. Okay, so the next holeless type of hydraulic elevator is called the roped holeless hydraulic elevator, right? So what they kind of do is they mix a combination of the traction ropes with the hydraulic cylinders to gain additional travel. So these can go up to, 60 feet of travel and even higher than that by some manufacturers. I wouldn't put them in higher than 50 feet of travel personally, but it's another way of kind of gaining additional travel with these elevators without going with the hold hydraulic cylinder. Again, it's a lot better environmentally because you're not digging into the ground, and a lot of times digging that hole into the ground comes with its own problems, and with that hole in the ground, you never know what's going to happen down there. So the roped hydraulic is another solution. A lot of times you'll see hydraulic elevators specified for freight type elevators just because the capacities of those types of elevators are a lot higher, and the hydraulic elevators can handle those higher capacities a lot better than your traditional MRL or overhead gearless or overhead geared. All right, so moving along, you have the next type of elevator system, which is called the geared elevators. And again, this is another existing elevator system that's in place widely throughout the area today. A lot of times you'll see these in a machine room connected up to with a DC motor and then a DC alternating drive and whatnot. So it's very energy inefficient. And again, it's a worm and gear drive as opposed to the new gearless, which is exactly how it sounds. It's more gears to accomplish one task, more or less. So it's not as efficient as the gearless, where it's just a single drive system. So these are still used today. I mean, you'll see them used for freight, basement traction, elevators, if you don't have the overhead and whatnot, offset, freight elevators and whatnot. But as far as like a standard passenger elevator, they probably wouldn't be specified for anything in this local area. So again, you have the machine located above. It can also be located in the basement, and then offset is another option, but that's a little bit of a tricky one. So I wouldn't recommend mentioning that to anybody, but they do get installed. So again, moving forward with the traction elevator, you have the gearless elevator system, which is the newest technology, right? So it's a drive shaft directly attached to the motor armature. Again, it's an overhead type system, and it's the most efficient elevator overhead drive system that they have today, right? So this is kind of where the MRL technology came from. Originally, the gearless elevators were designed from the geared elevators, and then from there they kind of downsized these gearless elevator systems and came up with the MRL system, which is coming up next here. So a few pictures there. And again, these can be used for high-rise application. The one all the way on the right there, big blue machine, is actually One World Trade. Okay, now the most popular elevator, which I'm sure everybody's familiar with these days, right? So it's the machine roomless elevators, MRLs, except that unless you're in Massachusetts, of course. But I'm still a big fan of the control room. They make a lot more sense than having the controller in the entrance frame. So what they basically did is they took the traditional gearless type machines and they downsized the machines, and they put everything that was in that machine room in the hoistway. Which gave it the term machine roomless, right? So, and they also allowed for the controller to be mounted in the hoistway as well, right? In some jurisdictions, this is still allowed. It's mainly in the Midwest. It's banned in an abundance of jurisdictions. I'm trying to think of a few around here. So definitely Massachusetts, and then New York State, some areas around there. White Plains, New York kind of bans it, and then New York City is a big proponent of having the machine room. California definitely, and things like that. So all right. Again, this is just going through everything that I've talked about. Controller installed in a separate room. Here's some examples of what the machines kind of look like. So you can see that they've all that a few of the manufacturers now have kind of moved away from the traditional ropes, which is your steel core ropes, and they now have these belted or webbing type belt systems that they use to drive the traction machines there. And in Massachusetts, these all have to be fire rated, of course. So I think it's pretty much fire rated belts are used throughout the area. Connecticut, for a while, I was catching a few non-fire rated belts in which they wanted the sprinklers in the hoistway, but in Massachusetts, of course, you're not allowed the sprinklers in the hoistway, so they definitely have to go with the fire rated belts. Again, the MRL evolved because of the machine technology. You got the smaller, more efficient machines for these lighter duty applications of the mid-rise and then even the high-rise. And they're also considered the green machines as opposed to the geared machines, and of course the hydraulic elevators. Okay, so this is going through the structural support methods, right? So most of your mid-rise MRLs are going to be all rail mounted. So all your loads are going to be carried from your overhead supports down the rails and into the pit. And that's true for all the manufacturers. They all have a product that pretty much has that. And then for a few of the high rise that's up to 300 feet of travel, they do have like a cassette type system, which I'm going to say the slideshow is going to do something a little creative here. And you can kind of see it kind of drops in there. So what that cassette type system is, and this is more particular to Otis elevator, it's a machine beam supported system. All the machine beams and the actual cassette is all by the elevator contractor and just kind of sits in the hoistway, and you have to provide the beam supports and everything else to make sure that that machine is adequately supported up there. So what is shown right there is actually what we would call a non-proprietary or non-standard MRL. It's actually a Delaware type MRL where they have that pancake type touring machine. I'm not going to get too involved in that. This area is pretty much like an OEM dominant market, so that your Otis, your TK elevator, your Schindler, and your Kone are pretty much the dominant players for the new construction market here. So you'll be seeing them pretty much on all the on all the new construction projects. And then you also have Stanley Elevator and then Delta Beckwith, which are sister companies of so Stanley Elevator's a sister company of TK Elevator, so they can install, you know, TK Elevator products, which is the Evolution product. And then you have the Otis Delta Beckwith Elevator, which is the sister company of Otis Elevator, which can install the Otis Underslung, the Otis Overslung, or the Otis Gen 3 Edge and Peak. They changed their name recently. They're always changing things on me. Keeps things interesting, I guess. All right, so again, it's just going through what the machine room list actually means. It basically means that everything in the machine room is in the hoistway now. So you don't have to worry about creating that overhead machine room. You don't have to worry about providing overhead access, rooftop access, code compliant staircase to the roof, or anything like that. This works good a lot of times when I'm doing feasibility studies for existing elevator hoistways where they want to rip out an existing machine and just put a new elevator in the hoistway, and they don't necessarily have, you know, code compliant rooftop access, which is very hard to do with an existing building, unless you're building a stair on the outside of the building, you know, of course. So they'll be favorable to the MRL design where you don't have to provide that kind of rooftop access there. They'll usually have like a ship's ladder with a roof hatch, or the spiral staircases I've seen, all of which, you know, are not compliant at all. You're not allowed to have a roof hatch to access an elevator machine room. Okay, some additional MRL notes. So with the MRL, right? So with the OEM types of product lines, a lot of what their product lines are designed around is efficiency and a pre-engineered product, right? So they have this assembly line system of pre-engineered equipment to kind of keep that cost low and provide you with a similar product to whatever everybody else is getting installed, more or less. So with that, you know, you're not going to get too much variation. So customization of certain components are very difficult. They are very costly because they have to be subcontracted out to other vendors. So what you can do is kind of get a little creative with the entrance frames, where you can do like cladding around the entrance frames. You can do powder coated finishes. But pretty much the industry standard for all the finishes as far as metal is stainless steel, right? So a lot of times with the designs these days, it's all black and stainless steel, all bronze and everything else. It looks very nice, but it's very expensive, you know, for the OEMs to subcontract out and to replace on their elevator equipment systems. So the wall panels, the ceiling, and the handrails is very easy to replace. They can easily subcontract that out, but it's more or less the front returns, the doors, the car stations, the push buttons, and then the entrance frames as well. Moving through the MRLs. So the MRLs are limited to either 150 feet of travel or 300 feet of travel. So 150 feet is kind of where your mid-rise MRLs is going to be limited, which I talked about, the rail supported type MRLs, and then 300 feet of travel is where your high-rise types of MRLs are going to be limited here. So, and you're also limited on speed, 500 feet per minute. A lot of times when I do the traffic analysis, 700 feet per minute is a tough one to pass through the general contractor, just because they usually push back because they know the high cost increase with the overhead gearless type system and everything that's involved with that. So they try to keep everything around 500 feet per minute around here, more or less. And not too many buildings are over 300 feet of travel. I don't think I haven't worked on any, but I think some of my colleagues may have worked on some, more or less, but definitely not that common. Okay, so moving through to the freight elevator classifications. So you have the three basic classifications, right? So A, B, and C. The most common one that you're going to see is Class A, of course, right? So that's your passenger type usage. Here's a little rundown with the pictures. So Class A and Class C3. Class A being the most common, Class C3 being the second most common, and then you have your Class B, C1, C2. Those are more or less for freight loading. Those are not for passenger type usage, right? So they don't meet ADA compliance, and they're not designed for passenger type use. So they don't have enough as the same safety features with the doors and whatnot. You have the biparting doors. However, with the Class A freight loading, which is for your general passenger use, that's rated for, of course, the passengers. And then your Class C3 is kind of a combination between the freight and the Class A. So it's a little bit of a branch there where you're allowed for more of a concentrated loading than the Class A, and you're still allowed passenger use, but you're not allowed to carry any forklifts or vehicles or anything like that on there, of course. So a little bit of information. So Class A is actually the rating on these on the elevators is actually designed around passenger use. So when you see like a 5,000 pound elevator, it's actually designed around how many passengers can fit in a 5,000 pound elevator, as opposed to how much can be loaded. So when you load a 5,000 pound elevator, you're only allowed a single load of 1,250 pounds, right? So exactly 25% of the total capacity. Whereas if you had C3 loading, what they do is they stiffen up the sills, they stiffen up the bottom of the car sling. You're allowed a total single load item of 5,000 pounds. Right, and then moving through to the specialty lifts, wheelchair lift on the left there. So I'm pretty sure a few of these have been installed around the local area, although Massachusetts is pretty adamant about getting a full-size elevator in there if it is designed as a floor. They're generally used for like secondary access points for a floor. So if you already have an elevator serving that floor, then and you need a second ADA access, the wheelchair lift is kind of what's put in there. And then also what's used for that is like stage conditions, where you have a stage or an auditorium, and they'll have that wheelchair lift alongside it as well. Next in line is a dumbwaiter or material lift, which you'll have for general freight type usage. You'll see those are very popular for kitchens or banquet halls, and also very popular for freight type usage in hospitals, with the hospital carts and whatnot. They'll tend to install a dumbwaiter or material lift. Those tend to be a little bit on the expensive side, just as for reference. So what people generally do is kind of just throw in a small elevator, more or less, because it ends up being around the same cost, especially in Massachusetts. Massachusetts has special codes around the dumbwaiter and material lift, and especially the VRCs that kind of make it a little difficult to kind of just install anything there. You have to do a lot of customization and whatnot. So. And then the less popular is what's called the residential elevator. So these are only inspected initially, and then they're not inspected any further past their initial installation there. So these are also limited in travel to, I believe, 50 feet of travel now. And they were previously 25 feet of travel. So 25 feet of travel in some jurisdictions, and then 50 feet of travel under 2013 ASME or 2015 building code. Moving through the specialty list, so what you see is the VRC there, which is used for more or less the industrial type freight usage. So that's going to be your heavier freights, up to 10,000 and above, all the way up to 50,000 pounds. They can get as big as you want them to be, and they're generally just within a confined space. So they don't usually penetrate a floor, more or less. So they're designed without a hoist space most of the time. Or if they do penetrate a floor, then they have to be rated and everything else, and special codes apply. I'm sure you're familiar with them in Massachusetts. So, and then again, the rack and pinion elevator, which may look familiar now that you're seeing a picture of it, but those are pretty much what you see on the mounted on the side of the buildings for your job sites. All right. So just going over the elevator operation requirements and components. So your basic elevator control operation systems is the constant pressure, which you're going to see on wheelchair lifts. Two-stop operation, which is exactly how it sounds. It's more for a two-stop hydraulic elevator. Simplex selective collective, which is your more popular one. So that's if you have a single elevator that's serving, 2 or more floors, you're gonna have that kind of operation. And then your duplex selective collective, which is 2 elevators that are working off of 1 riser, and your automatic group, which is a group of 3 or more elevators that are working off of a single riser. And then you have your destination dispatch system, which some people may be familiar with. It's becoming more popular throughout the Boston area, especially in office buildings. Pretty much all office buildings are being installed with that today. Various operating modes are attendant service, which I don't think you'll ever see unless you're on an older freight elevator or something like that. Independent service, which is provided for the building to kind of take that elevator out and use it for service needs as required. Your inspection service, which is for the elevator mechanic to run that elevator at a certain speed and whatnot. It's basically the same as independent service, more or less. So you'll most of the time you'll just have the independent service switch in there. They never really install the inspection service. Your firefighter emergency operation, phase 1, phase 2, again, code required operation. I'm sure everybody's familiar with that. Swing car operation is very popular nowadays, especially with the requirement for the 2 fire service access elevators. So frequently what they're doing is they're putting 2 service type elevators in your main passenger core, right? And you want to be able to utilize those service elevators for what they're designed for, which is service type use. So they'll be on what's called a swing car operation, which will pull one of those cars out of that bank and operate on a riser separate from the group riser, right? So it's usually on like a key switch. It's designed for only building use only. And what happens is when you activate that key switch, then that riser pull buttons will pull that car out of the group, and it'll operate independently of that group. So in another case, so you're not over there chasing the car going up and down and trying to get the right car that you need to serve the penthouse. So I'll use that for service cars that are provided in passenger banks, which is pretty popular in residential type buildings. And then also if that service car serves the penthouse floor or serves additional floors other than the main group of elevators. So that way the building super or whatnot's not constantly chasing those elevators looking for that correct one there. Executive priority service operation, not too popular around here, I guess. Not too many VIPs that really need this, but it's basically priority service where you would swipe your card reader, and then that elevator would come down, pick you up, not stop at any other floors, and then take you to your destination floor. hospital emergency service operation, MA emergency medical service. I'm sure everybody's familiar with that. So that's required for every single elevator, every single building, excuse me, every single building, one elevator that serves all floors of the building in Massachusetts has to be provided with that emergency medical service. So this is just going over the interface just to show the difference between the conventional dispatch and then your destination dispatch. So with your conventional dispatch, you have your regular button of hall push buttons, right? So you have to physically touch that push button to call the elevator or register a call. And then you either have the hall lanterns or the car lanterns light up, which achieves your ADA provisions, right? So it provides a direction of travel. And then inside the car operating panel, you have the push buttons to activate which floor you want to go to. And again, that's the most common elevator type of most common type of elevator control system. Calls are placed at the push button station in the hall. Destinations chosen from inside the elevator. You know, you can have multiple people that are going to different floors and they can each select which floor they want to go to. Versus the newer technology or the smarter technology, which basically consolidates people going to similar floors. So this is called the destination dispatch technology, which consists of this keypad. It's more or less like an iPad touch screen, right? And they can even operate off of just a card swipe where you can just swipe the card and it'll take you to your destination floor, your pre-programmed floor. And then if you needed to change it, you can just kind of hold the card over the card reader device and it'll allow you to select from different floors. So that way it's kind of like a touchless technology, more or less, right? So we saw a lot of people, you know, interested in this type of technology, you know, during the wake of COVID and whatnot. But pretty much once they saw the price tag of adding the destination dispatch to their systems, they kind of deferred from it and we're just kind of going back to the conventional dispatch. However, if they did have an office building, you know, and it was over 10 floors, they were probably putting in this system just because it is becoming the norm, especially in the city of Boston. Right, so your typical floors have less units because you're not seeing too many people using the elevators at the same time as you would at the main lobby, where you're going to have that heavy influx of people at one point in time. Right, so your main lobby is going to have as many as 3 to 4 devices, depending on how many elevators you have in a bank and how spread out they are and whatnot. The main goal when you're designing for these destination dispatch fixtures is to not, you know, allow for a backup of traffic, right? So if somebody has to wait in front of that push button station and there's not one that's actively available, and then you have people backing up on top of that and they're blocking elevator entrance doors and whatnot, it creates kind of a traffic jam in your elevator lobby, which is not good from a traffic analysis standpoint and not good from an experience standpoint. So you definitely want to try to avoid that at all costs. So another item which comes with the destination dispatch system is your static or dynamic car identification system. So it's not code required to have these light up at all, and it just has to be located adjacent to the elevator entrance frame. So the code doesn't really define too much criteria for these. I think they should probably light up. I think that's a lot more easier for people to see. However, the standard ones from the OEMs tend to be, you know, pretty atrocious looking, you know. So a lot of times architects will just come up with their own custom signage that they want posted above each elevator entrance landing. It's also cheaper that way too, because you kind of take that scope out of the elevator contractor scope. And then another additional item is your car jam registration indicator, and that's for your ADA provisions there. Additional braille signage, right? So you have to indicate which elevator it is. So the biggest issue is people press the push button destination dispatch touchscreen, right? And then they forget which elevator they're going on to, right? Everybody's human. They got a million things on their mind, especially these days. And so you want to make sure that elevator is adequately provided adequately with signage, and then also indicates, which floor that elevator is going to on the jam there. So when the doors open, they'll see that the elevator is going to their indicated floor, which gives them confirmation as well as the elevator identification number. And even so, then again, you definitely want to have additional, pads there. Frequently with the turnstiles, people will swipe their card. They'll forget which car it was read, and then you want to have additional stations there, so that way they can press the button again and then register another car. It's no car or call buttons. That's an example of what the destination dispatch fixtures look like. Each manufacturer kind of has their own design for what these look like. This one pictured is Kone. All right, so it's basically a touch screen, more or less. You also have your ADA provisions on there through the ADA sign there, which would enunciate, which floor and which elevator you're going to. All right, so this is going through the various operation modes, excuse me. Attendant service is exactly how it sounds. It's a car controlled by an attendant, right? It's very rare. You won't see those in any of those passenger cars. Even when the elevator is used for construction use, right? That's not attendant service. It's more or less it's an attendant operating the car, but it doesn't have the push buttons or whatnot. He just has the car on independent service and he's operating it that way. So again, that's the independent service, right? So it's a constant pressure type operating system, right? So you have to hold down that button to get the car to operate, which is I don't know if anybody's seen the attendant on the construction use elevators use that before, but if you're wondering why he's holding down the button, that's what he needs to do to get those cars to respond. Inspection service, which is basically the same thing as independent, it just limits the speed a little bit more. And again, that's used for technicians. And then your hoistway access operation, that's used for the technicians working on the elevators, right? For the safety of them, they want to make sure that they can access the elevator pit, the elevator overhead, and then ride the car up and down the shaft as needed, right? So that's provided through a key switch in the terminal landings at your lower and your upper landings. But definitely not for regular passenger type use. Swing car operation, which I discussed, it will take an elevator out of a group so that we can use it on a separate set of risers. It's good for when you have a service car and a passenger bank, or if you have an elevator that's serving another floor. Another way around this is to install a destination dispatch system. So that is another option. Executive priority service. Again, I went over this. Express modes to your destination floor, generally used for VIPs and whatnot. Not very popular. I haven't really done too many of those around here. And your hospital emergency service operation, again, required on one elevator that serves all floors of the building for every single new construction building. And then if I can, I will put it on the existing buildings as well. So this is going through your firefighter's emergency operation, which is a code requirement. It's divided into phase 1, phase 2 operation. Phase 1 being at the main recall call switch. Phase 2 being at the car station, right? I also like to put the phase 1 call switch in the fire command center for all buildings, especially if you have a high rise, or what I'd like to defined as a building code high rise, which is above 120 feet. Not the Massachusetts high rise above 70 feet there. And a big thing that came in with the 9th code edition, which I'm sure a lot of architects felt, is the fire service access elevator requirements, right? Which is required for a building with an occupied floor more than 120 feet. You need 2 fire service access elevators that service all floors, right? And hopefully they change that. I know they're looking in the 10th, right, to change it to the below garage levels or from the lowest floor from fire department access, right? So you don't have those fire service access elevators serving the garage areas anymore. It does a little bit, it does make things a little tricky as far as from a traffic analysis standpoint, because you're kind of creating multiple lobbies. Generally with a traffic analysis, you want to have that single lobby at floor 1. You don't want the elevators going down into the parking garage and picking people up. From an efficiency standpoint and traffic analysis standpoint, it definitely works a lot better that way. All right, and here's the code section I was discussing, right? Every floor of the building, which I've seen the later versions of the code and they seem to have changed that, which is good. It's definitely coming up on a few of my projects that they're expecting construction under the 10th. They're trying to do predetermine, what that's going to be and try to save some costs on those service elevators there. Serve every floor, automatic sprinkler system prohibited, right? Another big requirement is to prevent the water from intruding in the elevator hoistway, which everybody was kind of like, what does that mean when it first came out? So they had the sill troughs were going around for a little while, and then people weren't sure if heels would get stuck in the sill trough. Plus those sills weren't really rated for any kind of service type use or heavy type use. So generally these fire service access elevators perform second duty as a service elevator. So those steel troughs definitely weren't provided with any kind of load rating or anything like that. After speaking with the code manufacturer. So what seems to be a popular choice is to kind of incline the floor away from those sills, or design your lobby so that way there's no sprinklers and there's gaskets around the door. And again, with the floor inclined, so that way the water would hopefully deter and go elsewhere other than the down the elevator hoistway there. So it is kind of strange when you have like a front and rear opening elevator and you have a fire service access elevator, a fire service access lobby on one side, and then you have a passenger lobby on the other side. That's where things get kind of tricky. We're actually running into that right now with a project, more or less because we have a second fire service access elevator across from the second one. However, the second one is in the passenger bank. So where do you put the fire service access switch for that second elevator? Because they're technically separate, So the code only allows you to have one fire service access switch. So it kind of makes things a little bit difficult there. Going through the minimum ADA requirements, right? So it's pretty much a 2,000 pound capacity, or as the industry says, 2,100 pound capacity. Probably won't see them that small here. Their 2,500 pound capacity is more for the smaller type elevators, right? But because Massachusetts requires the stretcher requirement for every single elevator, you're pretty much locked into either the 3,500 pound car or the 4,000 pound car. Right, and then sorry, I skipped over that one. So for existing construction, it's a little bit different. You're allowed a little bit more leeway there, but the clear inside dimensions cannot be smaller than 48 by 48, right? And here's a basic diagram of what the stretcher handling elevators kind of look like. So you have your basic 84-inch stretcher compliant elevators, which are your 3,500 pound and your 4,000 pound elevators. A lot of architects like the center opening doors. I like them too, especially because they're the fastest operating doors in the industry. So from a traffic analysis standpoint, they open and close the fastest, and that's going to really affect your floor to floor times and really make that elevator a lot more of an efficient driving system, right? So the 4,000 pound car is definitely the more popular choice. And then if you wanted to just get away with a smaller car, which is roughly, exactly 1 foot less in width, that's your 3,500 pound car, right? So it's 6'8" is your 3,500 pound car in width, and then 7'8" is your 4,000 pound car in width. And then the 76-inch stretcher is not around at all today. I haven't seen it in a while, right? So that is not allowed for new construction under most areas. I think Maine actually has one area where they still fall under the 76-inch stretcher code, but I'm sure they're going to update that soon enough. So counterweight safeties, right? Basically what you have with the elevator system is this big hunk of steel that's attached to the car, and the code states that you're not allowed to have that big piece of steel without a safety on it above an occupied floor, occupied area. So what is an occupied area as defined by the code? It's basically any area that you can crawl down into, or any area that you can get to with any kind of easy force. Basically they want you to be Superman to access that elevator, more or less, right? So you can't have standard wall construction or anything else blocking that area underneath the pit. It has to be like a CMU or poured concrete type wall. Frequently what we'll do is, if we don't want to provide the counterweight safeties, is we'll just bring the core walls all the way down of the hoistway. That way it completely blocks off that area underneath, but it doesn't always happen. Counterweight safeties are, something that has to happen on jobs from time to time. So this mechanical device is attached to the counterweight frame, and it's basically an additional safety as opposed to the safety that's provided on the car sling, right? So it'll prevent that, it'll stop that counterweight from crashing down below that floor. It'll actually attach itself to the rails and stop the counterweight from moving further down, similar to the safety that's provided on the car sling. However, when you do provide the counterweight safeties, one thing to note is that it does add dimensional increases to whichever side. Yep, here. Oh, I think that goes into it. Yep. So it does add bigger hoistway dimensions in the direction of the counterweight, right? So it's either side counterweight or a rear counterweight, whichever is being designed is actually going to increase the size of the hoistway. And then some manufacturers require actually a deeper pit or more overhead to account for the counterweight as well. And then in addition to that, you're also going to have additional loads that are going to transfer down those counterweight rails when that safety is applied to the counterweight, that are going to transfer down to the pit, that need to be accounted for structurally as well. If you're working with like a very tight pit with pile caps and everything else that you kind of have to watch out for, that can sometimes be an issue, because structural is not necessarily keen on seeing that. It's not too common to have the counterweight safeties. They're usually just used to seeing the safeties applied to the car rails. So that does come up from time to time. All right, getting into elevator cabs. I'm just going to go through all these sections here just to talk through them real quick. So I think the best way to kind of go over the elevator cabs is to talk about, what's actually part of the pre-engineered products from the OEMs, and what can be easily customized, right? So I get this question a lot from the designers on the various projects that I work on, right? So the front returns, doors, right? It's a shame you can't really see my mouse here, but front returns and doors and transoms right there are what's comprised of the car station. So it's basically the front of the elevator, and this is this is what's missed most times when you provide like an architectural drawing. People tend to forget about this wall because they think of the cab in terms of the 3 walls or 2 walls if you have a front rear opening, and then just the ceiling. However, this is the hardest part to customize from those manufacturers. It can be done, you can do like a powder coated finish, or you can get custom metal, stainless, bronze, or can't think of anything. A black and stainless steel is another popular one. Are for that metal finish. However, they have to subcontract out those metal panels and essentially get them installed on the elevator. So they're shipping the elevator with the stainless steel panels, or removing those panels, buying the panels from another vendor, and then installing them on site. So that's completely different from the 3 wall panels in the cab, right? So the 3 wall panels can be easily customized through a local vendor, but with the cab interior, right? So they'll hire a local vendor like Draper, for instance, and they can provide a custom cab interior and install it in site. So the elevator contractor will just ship to the site their wall panels for the elevator cab. They'll build the elevator cab as they normally would, and they just wouldn't install any finished panels on the actual wall panels for the elevator cab. Same thing goes for the drop ceiling, right? Can be easily customized. However, the popular choice is generally the recessed LED or the cove lighting for most of your design, which pretty much all the manufacturers have as an availability. However, I do get requests for custom ceilings from time to time, but a couple of things to note with the ceiling. So if you are doing like a custom ceiling, there is an access hatch that has to kind of be carved out, and they can kind of hide it behind the 6-panel LED drop ceiling there. So actually one of those panels will pop up, and then you can have access to the hatch. But if you're trying to get like a look with a seamless LED drop ceiling, there's still going to have to be a seam more or less for the access panel. However, the local vendors are usually pretty good about kind of figuring out a design to mitigate that, so that way you barely even see it, more or less. So another thing is handrails. So they're not required by code for some jurisdictions, not Massachusetts. According to 521 CMR, you need at least 1 handrail in the elevators. However, other jurisdictions you're not allowed to have, or you don't need a handrail, more or less. However, it's always good just to add at least 1 handrail, or generally a handrail on each finished wall panel. Next part is the base. It's typically like a 4-inch base, which gets mounted behind the finished or removable wall panels, right? And then your finished flooring, of course, which is all done by others, and it's installed by the elevator contractor. There's usually a limit on the finished flooring depth, right? So that your recess is generally limited to 3/4 of an inch, just for reference for future projects there. A 1/4 of an inch seems to be popular, or if you want to do like a tile and whatnot, you generally have to go with like a thin set tile to be within that 3/4 of an inch design criteria. All right, moving along with the car operating panel. A big pet peeve of mine is this no smoking engraving on these car operating panels. They're definitely not required. I mean, you're not allowed to smoke in the building these days, so why would they have it on the car station? Every single job that I do, that no smoking sign ends up on the shop drawings, and I usually mark it up to be removed. So I think it looks much better with the cleaner look, as opposed to having that big ugly no smoking sign, especially if you're paying for this expensive elevator. You don't want that big ugly thing kind of sticking out there. Another component of it is the car position indicator, right? So you see that red arrow with the number on it. That's your position indicator, determining where the car is in the actual hoistway and with regards to the elevator landings, right? That's all required by code. The same with your emergency light. Some places you can get the emergency light in the actual ceiling lights, right? Which again provides for a cleaner COP panel. It's a little difficult from the OEM, so we don't see that too often around here. Some of them have like kind of like a slimline light that, you know, doesn't look as bad as that one, but generally they're all provided in the car station there. You have your fire service cabinet. This one appears to be an older generation car station that they're showing there, because you need the additional cabinet for all those key switches and whatnot. You have to update that, but in addition to that, you have your 4 push buttons, right? Braille, which is required per ADA. Your push buttons are required to be at certain heights, certain reach requirements, 35 inches to 48 inches, right? And then Massachusetts specifically, you have to have a 35 inches on center to the car alarm button, and also the car stop switch, which has to be keyed. Door open and close buttons. Sometimes you'll see a door hold button. Again, it usually tends to mess up the layout of the buttons, so I try not to put the door hold button on a lot of my jobs. It's kind of ends up being this one single off button that will mess up the nice layout there. So they tend not to go on there. I don't think they work anyway. I every single one that I've ever tested usually isn't hooked up. So I think it's just for people just to pound and hit on to make themselves feel better about the elevator doing something right. Emergency communication and alarm button. We talked about that. So the alarm button has to be 35 inches per mass. And then your emergency communication button, which is basically the phone. Everything's wireless communication now with the phone integrated into the car station. The newer code allows the communication failure device, right? So at the main car station, you have the device which will signal if there's an interruption in the actual car answering system. So if the phone is disconnected for whatever reason, a lot of times if the signal is dirty for those digital type phones, I've come across that alarm system will actually go off, and you'll get that loud beeping noise at the main car station there. So it's best to kind of just put a traditional phone line in these, connected up to the controller, because that way you'll get that constant signal and you won't have that issue. All right. And in the lock service panel, you have your various devices, key switches, different types of operation modes. You have your independent inspection, which is rarely installed. Fan speed, generally it's a 2-speed fan, right? High and low. Light dimmer sometimes. Emergency light test button and indicator. And then you also have your car designation engravings, if you can get it. Generally, most of my projects, I like to engrave the car capacity and designation as well on the access panel. And then in some jurisdictions, you actually have to have, similar to Massachusetts, you have to have the inspection certificate posted on the actual car station. For some reason in New York, they don't code require this, so they just put that you have to state the location of the inspection certificate on the actual car station. So kind of interesting there. So I've had instances where if the description isn't describing it enough, that the inspector will actually fail the elevator, right? Because they'll just put like a general statement like inspection certificate located in building maintenance office, but they won't put the actual maintenance office number or the floor or whatnot. So I think it's easier just to put the inspection certificate in there personally. So the newer code, I'm not sure if it's coming in under the 10th, but actually requires audio visual type car station system, right? So it's for people using sign language, because previously, how would they be able to indicate that they were in kind of any kind of distress? So the audio visual can consist of a video camera that actually will be utilized by the answering service, and then the person can sign and indicate that they're in some kind of trouble or anything like that. So this isn't a code requirement in Mass. I'm not sure if it's coming in under the 10th. I've only had it go in under New York State jurisdiction, and I haven't seen the infrastructure supported yet. So it's going to be interesting to see how the industry kind of responds to that. They just started coming out with the fixtures and whatnot in response to that code change. So I'm pretty sure it's going to come to Mass soon. Here's a breakdown of your basic elevator fixtures, right? So you have your hall push button station, pretty basic, right? Light up, calls the elevator to your destined floor, right? Or to your, to the floor that you're on. Then you have your position indicator, which isn't required per ADA, right? So it's just to give people a sense of where the elevator is located in relation to where they're at. So if you're sitting at the lobby floor, which is at floor 1, and then the position indicator indicates floor 5, then you know that the elevator is, pretty far away from you, and that you're going to be waiting there a little longer. It gives people, somewhat of a better experience, kind of indicating where the elevator is going. And then you have your lanterns, either your car or hall lanterns, right? Some people think that you need both the car and hall lanterns to meet ADA compliance. That's not true. One or the other will meet ADA compliance. So the hall lantern is actually mounted on the outside of your elevator entrance frame. So as you walk up to the elevator, you would actually see the direction arrows for the elevator indicating the direction of travel to meet your ADA provisions. And the car lantern actually rides with the elevator car. So it goes up and down with the car on the inside of the jam. One thing to note, though, is when the car lantern is positioned on the inside of the car, they generally like to keep it on one side. They don't like to install 2 car lanterns on both sides. So technically, to meet ADA provisions, you have to have that hall push button station within view of the car lantern. So that's the opposite side that it's located in the cab. So if you have something on that wall on that opposite side, where you change it from landing to landing because of a door or something like that, it technically doesn't meet ADA, and you need that second car lantern there. The big difference is cost, of course, right? So the car lantern, you just need 1 lantern for all your floors, whereas the hall lantern, you're paying for as many fixtures as you have floors, right? So next is the fire command center panel, generally provided for elevators, that are, for elevators that are in buildings above 120 feet of travel, or if you have multiple elevators, multiple banks, emergency power, a lot of stuff kind of going on there, we'll usually always spec that fire command panel, and that's going to contain your position indicators, your indicators on your emergency power, whether the car is operating on emergency power, whether it's not. If there's multiple cars within a bank, it'll allow you to switch between those banks for the emergency power. You'll also have your fireman's phase 1 emergency service. Frequently, I'll put the car to lobby key switch on there so you can call the elevator down manually if you want to. And then you also have your car at lobby indicator light. All right. How are we doing on time here? Pretty good, right? Do we have until 10? Okay.
Yeah, we have until 10. So you've got a little bit of time still, Sean.
Okay. All right. So going over the basic elevator applications, capacities, and speeds. So your passenger elevator capacities, right? So your standard passenger elevator, generally used for passenger type usage, for moving large amounts of people, not used for service type usage and whatnot. That's your 2,000 pounds to your 4,000 pound type elevators. It's standardized throughout the OEMs, right? And then you have your service elevator capacities, which start at 4,500 and then go all the way up to 5,000 pounds, and then 5,000 pounds AIA if you need that extra foot, right? So the extra foot helps out frequently with the electric bikes these days. They seem to be like 9 foot in length. So you definitely want to spec that larger elevator there. Hydraulic elevators, they're limited in speed, 50 to 175 feet per minute. They don't go too fast. Your gear traction elevators are going 150 to 350 feet per minute. MRL speeds 150 to 500 feet per minute. 500 feet per minute is kind of where they top out. And then your gearless traction elevator systems go from 500 to all the way up to 2,000 feet per minute. Okay, so going back to the classification, remember I discussed the Class A loading requirements. So this is basically what the code says can fit in a standard elevator there, which is completely unrealistic. I think if I saw that many people in the elevator, I would probably turn around, especially these days, right? In America, especially, if you see like 3 or more people in these elevators, you're probably going to wait for the next one. And this is more pronounced now with COVID than anything else. So, but that's the way the code defines the capacity. So the capacity isn't necessarily how much weight can be handled by the elevator, it's how many passengers can actually fit in the elevator. And they use 165 pounds divided by the capacity, and that's kind of where you get the rough estimate of how many people are going to be in there. So I'll get into this a little bit more when we talk about the traffic analysis. So going through the application, so you have your hydraulic elevators. They're generally low rise, right? You can get those roped hydraulic up to 60 feet of travel. Not recommended, they're extremely inefficient, right? So they use a lot of horsepower, especially if you're going up to 60 feet of travel at like say 150 feet per minute, you're probably looking at like 250 horsepower motors and whatnot. The maintenance on them is high, energy consumption is again high. However, your pit depth for them are pretty minimal, and then your overhead requirements are minimal for them as well. So the hydraulic elevators definitely have their use in the market. However, it's kind of like a dying market trend, right? So a lot of people are moving towards the gearless, they're moving towards the MRLs. The cost of the MRLs these days versus the hydraulic elevators is about one and the same. So there's not much difference between a standard holeless hydraulic elevator and a 2-stop MRL elevator. All right, so comparing that to the machine roomless elevator, right? So I can go 150 feet per minute to 500 feet per minute, up to 300 feet of travel, right? And your pit depth and your overhead, of course, is going to be increased a little bit more. However, that's generally not an issue for most applications. And like I said, if you do have an issue with overhead and pit depth, there is options. There's something called a collapsible tow guard, which you can install on the machine roomless elevator. Some jurisdictions like Connecticut actually allow Otis Elevator to install a 4-foot pit on their MRL traction elevator. Not here in Massachusetts, of course, but there are some available options there. Then you have your gearless traction elevators, which it's more or less used when you get into that 700 feet per minute that you need to meet the traffic analysis demand, right? So if you don't have enough elevators, or you can't provide enough elevators in your core, and you kind of have to need that extra speed there, 700 feet per minute to get everybody moving throughout the building, then this is kind of where the gearless traction elevators really, stand out. Again, they're used for, freight type usage, higher ranges of travel, these higher buildings, above 300 feet for these high-rise buildings, which again we don't really see too often here. And then you have your gear traction elevators, which are generally used for your freights, low rise, 150 feet per minute. Some manufacturers, or some clients actually prefer the geared and the gearless elevators. So you'll see them spec. They don't like the MRL, the OEM type equipment. They want to go with what's called like non-proprietary in the industry and whatnot. So, all right, so this is going through the passenger elevator entrances. So these are your two basic type of entrances, your 36 and your 42-inch single speed side opening doors. And then your 42, 48, 54-inch center opening doors. The industry standard though is the 36 and the 42 side opening doors. And then your 42 and 48 center opening doors there. And again, the center opening doors are probably the most popular, right? Because they're the fastest in the industry. So from a traffic analysis standpoint, they definitely stand out. And then these can also, and then you also have your 2-speed side opening doors, 2-speed center opening doors, right? Generally, the 2-speed side opening door is popular on your 4,500, 5,000 pound, 5,000 pound AIA type service elevators. The 2-speed center opening doors you won't see unless you're working with like a custom type of elevator. That's kind of to get the wider elevator doors and whatnot. And then if you want to get really creative, you have something called the 3-speed side opening doors, which I don't think anybody's seen here. And I definitely not recommend it, obviously, because they look like a mechanical nightmare. Right. So I've only used them special case by case scenarios, right, where I've actually had elevators too small and too small of a shaft that can actually fit, the 2-speed doors. I have to have the 3-speed doors. They do not work well at all. You have a lot of issues, a lot of downtime on the elevator and whatnot. I haven't seen anything like that around here. But there is some applications, mainly in New York City when they were building up those rundown areas. A lot of times they didn't want to replace these elevators, so they were kind of stuck with the smallest elevators. You can barely fit a single person in there, and they have to meet passenger requirements, right? So you have to kind of stick those 3-speed doors on there. So, but I wouldn't bring them up though. All right, so here we're going over some building consideration, right? A big thing that you may have come across is what's called stack effect. So it's basically the cool air coming in and the warm air trying to get out of the building, right? So it's going to create a lot of chattering of the elevator doors and also degrade your elevator ride quality, right? Because it creates too much pressure within the elevator shaft. It's basically that movement of pressure, the negative pressure at the lower levels, the cool air, positive pressure at the upper levels. And again, it's more pronounced the taller the building is. I haven't come across it too much in this area, but the buildings are getting higher and higher around here. So greater temperature differentials. You'll get that whistling sound. Again, the chattering of the doors and whatnot. And in some cases, it can actually be so bad that it'll shut down the elevator, right? Because the elevator is moving too much to where the safety devices can't register correctly or activate correctly. And, that causes issues. The easiest way to prevent this is to kind of have those swing type doors there at the lobby. So you don't want any open windows or anything like that at your main lobby to kind of mitigate that cool air from coming in and taking over the building there. Again, that's going to be the airlocks to the outside there. And you also want to limit the open windows in your upper floors as well. The second item is what's called the piston effect, right? And again, this is another high-rise application where you see like a single or even a duplex elevator within a single shaft. And as the elevator moves through the shaft, it creates what's called a piston effect, where it's pushing a lot of that air through the shafts and also causing chattering the doors, the elevator to act erratically, degrade your ride quality and everything else, because that air is trying to escape as the elevator pushes through, similar to like how a plunger works through the shaft. Sorry, went back on there. And again, that's for high speed whistling through the entrances, noise, degrade your ride quality. A way to migrate that is to kind of create like a larger shaft. So It's pretty common if you have, not so much anymore, but before the 2 fire service access elevator requirements, you just had the single service elevator, the fire service access elevator for a really tall building, because it's generally separate from your passenger elevator bank, right? Where you would get this condition where you'd have this single elevator going all the way up 300, 400 feet of travel, and then trying to escape all that air there. So a way around this is to kind of oversize the elevator shaft, right? And then provide relief vents throughout the shaftway as the elevator goes through. Sorry. Another meeting popped up here. All right, so wind sway is another condition. Again, we generally don't see it here. We don't see buildings in excess of 450 feet too often here. So basically, what a way to mitigate this is the elevators actually provide with sensors to compensate for the wind sway of the building. Or if there's a very windy day and whatnot, it'll actually shut down the elevator or shut down a number of elevators. That way the elevators can operate correctly and whatnot. Every day in Massachusetts seems to be a windy day, apparently. So it would be pretty common if we have these tall buildings here, but luckily they're not too common here. So. All right, getting over to escalators and moving walks here. So your basic escalator comes in 24, 32, and 40-inch, step widths. The difference between the step width is how many people you can actually fit on each step. The 40-inch is probably the most popular. That's where you can actually fit 2 people side by side, and then 32-inch being the second most popular, where you can fit like 1 person in baggage, and then 1 person each step, again with their baggage as well. Popular for airports. Standard speeds 100 feet per minute. Your rise up to 20 feet standard without intermediate support. Vertical incline is a standard throughout. The code is 30 degrees. I'm going to get into the balustrades here. So here you have your solid balustrade. So your design to finish elements for your escalators consists of the balustrade, that consists of the skirt, your step finishes, your handrail finishes, and everything else. You can even add LED lighting and everything like that. Frequently what they do is they clad the outside of these escalators, and provides like a really nice appearance and look. They'll usually clad the outside. They'll do specialty cladding on the inside where the skirt is, which is shown right there on the bottom. The glass balustrades are also pretty nice. And getting into the escalator support details. So the escalators are rather simple, right? So it's basically a drop and play type device. So you have your support at the upper end, and you have your support at the lower end, which changes and varies per each manufacturer, your seismic supports for each of those upper and lower ends. And then if your travel's high enough, then you have what's called intermediate support, which is an intermediate support in between the escalators. Your safety zone requirements. Per ASME A17.1, you're required to have your safety zone in front of the escalators, of course. There's specific code requirements, which basically drills down to no less than the width between the center lines of the handrails plus 8 inches for your total width. And then for the length, it's no less than twice the distance between the center lines of the handrails. So this varies per each manufacturer, but generally between 6'6" and 7'6". Here's a little bit of application for each of the escalators, right? So you can have that crisscross type situation there, which is pretty popular. And then you can have your parallel stacked type arrangement there. All right. Working through time here. So I'm going to go through the elevator traffic analysis portion pretty quickly. So basically, when we're conducting the elevator traffic analysis, the biggest things that come into play are your floor-to-floor heights and your total travel.
as well as your population per floor, and of course your population density. A lot of times, people will compare buildings to other buildings and whatnot, but these are very important factors, and they differ per each building, and they're going to significantly impact, the overall waiting times and whatnot. You may be close on one building, but in this building, your floor to floor heights are 18 feet as opposed to 15 feet. And it's going to significantly change everything. The design criteria for these is basically your average waiting time or your interval. There are two different levels of measurement. They're the basic levels of measurement for your elevator traffic analysis, and then also your average time to destination, and also your car loading. I'll go through all those. Another big consideration is your population traffic patterns, right? All this comes into play with the arrival time fluctuations, absenteeisms, weather, flexible work times, right? People working from home, may not have 100% capacity, especially nowadays. Counterflow of traffic, cafeteria, meeting rooms, libraries, all that stuff comes into play here. This just basically goes through the interval. For this area, the architects around here are pretty familiar with the average waiting time. So the average waiting time is a lot easier to understand than the interval, right? So the waiting time starts when a person registers the hall call and ends when the responding elevator arrives, right? It's exactly how it sounds, average waiting time. And for your basic Class A office building, we wouldn't want to see an average waiting time exceed 25 seconds. So 20 to 25 seconds, 20 being very good, and then 25, being on that lower end there. So residential buildings is a little less strict. So you have your 25 to 35 seconds, excuse me. And then your hotel 25 to 30, and then garage 25 to 30. Time to destination, again, it's exactly how it sounds. Basically, it's the time the passenger spends registering the hall call to the time he's exiting on the destined floor, right? You want to see less than 90 seconds. And that's kind of where the destination dispatch system really comes into play there. So your time to destination significantly decreases when you have the destination type system in place. Same thing with your car loading, right? We talked about the loading of a car. It's a standard 3,500 pound car, would be 21 persons. Have you ever seen 21 persons in a car? It's completely unrealistic, right? So 60% of that is about 12 people, which I still think is a little unrealistic. I don't think I've ever seen 12 people in there, but that's kind of what we look at. And then also your population densities, right? Office buildings, 150, 225 net usable square foot. Population density for the frequently, a lot of stuff that's being installed in new construction is all these lab and office mixed use, right? And we're seeing 175 to 225 net usable square foot population density, right? Typical single tenant office building in New York City, or at least what it used to be, was 150. And then to gather your population for your hotel, parking garages, residential buildings, we basically calculate how many parking spaces, how many rooms, or how many bedrooms per each person at those values there. Here we go. Here's the important stuff, right? So general rule of thumb when you're designing a new construction building, right? So 40 to 50,000 square foot gross floor area per each passenger elevator. So you take your gross floor area and you divide it by those values, and you'll come up with a rough estimate for how many elevators. And then hotels, one passenger elevator per 100 guest rooms. Again, these values are just rules of thumb. They may change, varying the floor to floor heights, and also how dense the population is and whatnot. And then garages, it's one elevator per 300 to 400 parking spaces. All right, this is it. This is the last section here. So as we talked about earlier, right, elevators are getting more green, sustainable. They're branching off into the sustainable realm there, right? With the gearless technology, with the MRL, makes things a lot more efficient. So they actually apply for some of the LEED qualification points, right? So material, energy, environmental sites, MRL technology, the dispatching algorithms with the destination dispatch. It's smart technology. It's a lot more efficient technology and everything else. So all these are good for the elevators becoming more and more green, right? Which is good. Again, going through the power saving technology, right? You have the old school motor generators and DC geared machine, right? That would probably be about like 35, 40 horsepower versus the gearless technology today, which is about 15 to 20 horsepower. So that's a significant decrease from what we were using previously. And then what we have today is also what's called regenerative drives, right? So regenerative drives take let me start by saying the regenerative drives were always in place. So they would take this power created by the elevator systems and just disperse it through a bank of resistors, right? Extremely inefficient. Why would you just not put that power back into the grid? So now they finally came up with the process of using, that additional energy and dispersing it back into the grid there. So it's basically working against the elevator machine that generates the power with the empty car going up or the full load going down against the counterweight and the force of the machine. And they put it back into the grid. Right. Advanced technology, destination dispatch system. So a lot of times when it first came out, it was marketed as, it could delete one car, which is it's not true. You can't delete one car when you install the destination dispatch system. What it basically does is it'll create an efficient travel consolidation type system for your elevators. So you can't delete one car. You'll provide better service throughout, better experience for your passengers. But as far as deleting a car, it was marketed that way initially, to try to sell it a little bit more. But now it's become more of travel consolidation. And then in the wake of COVID and everything, people with the touchless technology and also the technology that they're we're using more and more today as we grow as a society. People like using the touchpads as opposed to the traditional push buttons and whatnot. So that's kind of where this destination dispatch shines. It also is a lot more programmable, so you can actually shut elevators down if they're not used. So it's a more power efficient. You can see what the elevators are doing. You can tell the elevators not to load so many people at one time, right? Or only take on so many people, less crowded cars. Another thing that was important during COVID, which a lot of buildings looked at and then they kind of steered away from once they saw the impact of it. So again, the different algorithms of programmable, everything's fully programmable through the smart technology. It's a smart dispatching system. This just goes over the energy code requirements, which pretty much all your elevators today that are installed all meet the energy code requirements. And that's basically going to comprise of your car lighting and your ventilation, right? So it should shut off when the car is not being used or unoccupied. Again, with the shaft ventilation, big thing that came in with the 9th was the shaft ventilation. They basically removed it from the code, right? So you're basically in previous installations, you would have an elevator shaft which acts as a vacuum, pulling your cooled or your heated air out of your building and then just exiting it through the ventilation that's provided in the shaft, right? Extremely inefficient. So they allowed for the mechanical designer to basically say that they don't need it, or just provide the closed vent up there, which is a lot more efficient, conserving all that energy and everything else in that cooled climatized air in the building. All right, that's it. Coming up on the ringer here. So any questions?
Sean, I think we had one question show up on the chat that asked, what is the average cost of an elevator serving 2 stories?
Average cost of an elevator serving 2 stories is probably around $150,000 to $200,000. So it depends on the manufacturer that the job's being bid to. It depends on how the job's being designed. The idea is to design for a competitive bid. So you want to design so that way that elevator can be installed and bid on by multiple manufacturers. A lot of times people will go to Otis Elevator thinking that they have the largest dimensions, but they actually have the smallest, tightest dimensions. So you're basically sole sourcing that job to Otis Elevator. And once they see that, they're going to increase their profit margin. And that 150 to 200K elevator is going to turn into 250 to 300K, just because they know that you're probably not going to change the hoistway dimensions more or less. So if you structure it around like a competitive bid, sort of like, exactly what VDA does on multiple projects, then you're going to have that best pricing from the multiple vendors. It depends on the vendors, their availability, what teams they have available and everything like that, but that'll give you the best pricing. And also your finishes too, which are going to affect that.
Thanks, Sean. I think there was one other question that came in just a moment ago, and then we'll probably sign off just to give everybody, since it's 10 o'clock. The question is, do you know anything about the history of why Massachusetts prohibits sprinklers in elevator shafts and elevator machine rooms?
Yes, because if you're stuck in an elevator and the water starts pouring on top of the equipment that's running that elevator, would you want to be in it? So it's you don't want water pouring on the control system, pouring on the machine system while somebody's in the elevator. What does the elevator do? It's going to shut down, it's going to short out, and then you have the possible entrapment while water's pouring onto the elevator. So that's why Massachusetts banned the sprinklers in the hoistway in the machine room.
Yeah, from experience, that's fairly typical across the nation now. It didn't used to be. Certain jurisdictions still like the sprinkler protection, and then you end up with a power shunt addition to it in order to stop the equipment before the sprinkler goes off, which is difficult.
Yeah, it's expensive, it's difficult. I still see it on projects in New York State. They still have it there,
Right.
but try to avoid it at all costs. So
yep,
it's best to keep it out. In New York City for hydraulic elevators, when you have that flammable liquid, you still need the 2 foot off the pit floor. You still need that sprinkler in there.
right.
So that is
Right.
another point to note there, but that makes sense because it's flammable liquid. And then anything with these MRLs, these gearless type of machines, nothing's flammable. Even the belts, you can spec them as being fire rated and everything.
Okay, great. Sean, this is great. It's a lot of information that you threw at us in an hour and a half. We appreciate you taking the time to talk to us.
Yeah, I didn't realize it would go that long. It was pretty intense, but thank you all. I appreciate it.
Yeah, thank you so much.
All right, take care.
All right, thanks everyone.
Thank you. We'll see you next
Bye.
month.